Okay, this is lesson 7.3, multiplying powers with the same base. The learning target for this lesson is to get you to multiply powers or exponential numbers that have the same base. Now, I'm going to go a little quicker in this lesson because you have the ability to pause and rewind and watch again if you need to. I'm also going to ask you at certain times to stop the video and fill in the blanks on the notes by yourself and then come back afterward and check. So, let's get going. In this table, in the first spot on your notes, you're going to notice we're multiplying two numbers together, 7 to the third times 7 to the second. The number, the bottom part, the 7, is called the base. So, first thing you're going to do in this problem is rewrite 7 to the third in what's called expanded form. That just means you're going to write it out 7 times 7 times 7, 3 sevens, and then 7 times 7, 2 sevens. Then you're going to count up the number of factors. What are the things you're multiplying together? They're all 7s. How many of them are there? 1, 2, 3, 4, 5. So you write out 5. Then you're going to take all these 7s that you're multiplying together and rewrite it as an exponential number, which is 7 to the 5th. So take the time right now, pause the video, write out all the answers to the next several problems by expanding them, counting the factors, and writing them as a product of power. Alright, so you should have come up with some answers that look like this. 2 times 2 times 2, 2 times 2 times 2, there's 8 of them, that's 2 to the 8th. In the problem that has the m's in it, this first m is just m, or you could also write it as m to the first power, knowing that if there is no exponent on a number, it's implied to be 1. So, here are some questions about this table. First of all, what do you notice about the base of the original products, these bases, and how it relates to the bases in the answers? Well, it's not a trick question. The answer should be obvious. The bases are the same. All these m's are the same as this m. All these 3's is the same as this 3. Second question, what do you notice about the exponents in the original versus the exponent in the answer? Again, not supposed to be a trick question. What you should see is there's exponents in the original problem, and if you add them all together, it gives you the final exponent. So what you should have written is the last exponent equals the sum of the original exponents, all those exponents added together. So what's the shortcut? Well, the shortcut is that if you have numbers being multiplied together and they are the same base, then all you have to do is add the exponents together. So there's a rule that we can write that applies to this shortcut. And that rule is this. If I have a number a raised to some power n, and I multiply it by another number that's exactly the same base, a, raised to some other power, then my answer is just a to the n plus m. Now that can be confusing sometimes when you write a rule and it's got a bunch of letters, so let's just do a couple examples. Example 1 says, write each expression using each base only once. Notice it doesn't say simplify. Simplify means make it as simple as possible. This problem just wants you to write it out with the same base. So in part A, I notice there's a 12 to the 4th and a 12 to the 3rd. The bases are the same. All I have to do is add the exponents. My answer is 12 to the 7th. That's it. I don't want you to figure out what 12 to the 7th power equals. I just want one answer with one base. So part B, negative 5 is in parentheses raised to the negative 2nd power times negative 5 in parentheses raised to the 7th power. So my answer is negative 5 in parentheses raised to the negative 2 plus 7 is positive 5. Bases are the same, add the exponents. Now you have to be careful because if I were to give you a problem that had negative 5 in parentheses to some power and positive 5 in parentheses to some power, those bases aren't the same, so we can't write it out with one base only. That one can't be done like that. Alright, take a second, complete the problems here, and then resume the video when you're ready to check your answers. Alright, 8 to the third and 8 to the sixth. 3 plus 6 is 9, that's 8 to the ninth. B, 0.5 to the negative third and 0.5 to the negative eighth. Negative 3 and negative 8 is negative 11. And the last one, 9 to the negative third, 9 to the second, 9 to the sixth. Add all those exponents together and you get 9 to the fifth. Okay, the second example just takes it a step further and asks you to multiply powers of expressions. So in the first example it says 4z to the fifth times 9z to the negative 12th. Now it looks like that there's two things being multiplied together, but really it's four things, because if I write out 4z to the fifth, that really means 4 times z to the fifth. And 9z to the negative 12th really means 9 times z to the negative 12th. So this problem really involves four things being multiplied together. Two of them are like bases. So one way to do this is to rewrite the whole problem in a different order by writing the number parts together, 4 times 9, and then write the z's together, z to the fifth times z to the negative 12th. And then you can just multiply. 4 times 9 is 36. Z to the fifth times z to the negative 12th. Add the exponents, you get z to the negative 7th. Now if you paid attention in the first lesson, you know that having a negative exponent isn't okay when you're simplifying. So I'm going to move that down to the bottom and make my final answer 36 over z to the 7th. Alright, part B. It looks like it has three things being multiplied together, but really it's six things. It's 2 times a times 9 times b to the fourth times 3 times a to the second. And again, I can rewrite this in a different order, putting all the numbers together. 2 times 9 times 3, that's these numbers. And then I can write the letters together, but I'm going to put them in alphabetic order so that all of the letters end up next to each other, like this. A times a to the second times b to the fourth. That way my a's are next to each other and it's easier for me to add the exponents. 2 times 9 times 3. The easy way to do it is 2 times 3 is 6. 6 times 9 is 54. A times a to the second. This first a doesn't have an exponent, so it's implied to be a 1. So 1 plus 2 is 3. That's a to the third, b to the fourth. And that's my answer. Alright, again, take a second now. Finish A, B, and C on your own, and then I'll give you the answers when you hit Alright, A, 5 times 3 is 15. X to the fourth times x to the ninth times x to the first is x to the 14th. B, negative 4 times 7 times 2, negative 56. C to the positive first, because 3 and negative 2 makes 1, and D to the second. Now a lot of times people get tripped up by this negative here and think, oh, I need to move the 56 down to the bottom because it's negative. You only move numbers that have negative exponents, so this number is top. The last one, there's only one number, it's 12. J to the second times j to the first is j to the third, k to the negative second, but you know the negative exponent gets moved, so it's 12 j to the third over k to the positive 2. Okay, the last example, example 3, has to do with scientific notation. So if you're given a number written in scientific notation, remember this little symbol means multiply, and parentheses mean multiply. So in this problem, again, it looks like two things are being multiplied together when it's really four things. So it's really just 3 times 10 to the 5th times 5 times 10 to the negative 12th. And you can rewrite it in a different order by putting the number parts together. 3 times 5, and putting the powers of 10 together, times 10 to the 5th times 10 to the negative 12th. Then you just multiply. 3 times 5 is 15 times 10 to the 5th times 10 to the negative 12th. Those are like bases, so I add the exponents to get 10 to the negative 7th. Now, there's one extra step here that doesn't make this answer the final answer, but I'm going to leave it like that. I'm going to ask you to finish this one in the same way, and then tomorrow, when you come to class, I'm going to show you how to take this answer and make it a correct answer written in scientific notation so that it looks like this. And maybe you can figure that out on your own before you get to class tomorrow. Okay, that's it for lesson 7.3. See you tomorrow.